Have you ever accidentally passed a customer ID where an order ID was expected and the compiler didn't complain? That's not a bad luck, that's a software design problem. And today we are fixing it in domain-driven design using the strongly typed IDs. Hey everyone, welcome back to my channel. If you are working with a domain-driven design or even just a clean code, you may have used the grids, integers or the strings as IDs everywhere. In this video, we will learn what the primitive obsession is and why the primitive IDs such as grids or integers are dangerous in your domain model, and how using the strongly typed IDs can make your code safer, clearer and more expressive. We will walk through practical C# examples using the domain-driven design. Let's start with a very common problem called the primitive obsession. Primitive obsession is a software development anti-pattern and a code smell where the primitive data types such as integers, strings, or grids are overused to represent the domain concepts. Let's see a classic example of primitive obsession. I have classes such as players, clubs, and stadiums in my league manager domain. And here I'm using the primitive data type Guid to represent the player ID and the club ID. At first glance, it looks fine, but here is the problem. As both player ID and the club ID are declared as grids, the compiler doesn't know the difference between the player ID and the club ID. It seems we are violating the basic principle of domain-driven design. In domain-driven design, your code should clearly express the business concepts, but when you use the primitive data types, your code loses its meaning. You can easily pass the player ID where the club ID is needed and vice versa. The invalid states in your domain becomes possible, and the bug sneaks in silently. The domain-driven design encourages us to model the concepts explicitly and not hide them behind the primitives. Strongly typed IDs provides us the antidote to primitive obsession. When we use the strongly typed IDs, we create a distinct type for each kind of identifier in our domain. Instead of saying the club ID is just a grid, we say it's a club ID. Similarly, we don't represent the player ID as a grid, we represent it as player ID. I'm creating a new class in my players features folder and let's call it player ID. I am going to mark this class as public, and the best way to create the strongly typed IDs in C# is to use the record instead of classes. And here I can specify the grid value as a property. To make these strongly typed IDs even better, you can also mark them as read-only and struct. The struct keyword will make sure that our strongly typed ID is a value type and not a reference type. Using the C# bracket here will give us the structured equality for free. For example, if we have two player IDs with the same value, they will be considered equal. Another benefit of using the C# bracket here is that you don't need to implement methods such as get hashcode, toString, and equals. The C# compiler will generate them automatically for you. The read-only keyword here will make sure that our struct is immutable. Without the read-only keyword, the player ID can be mutated. Combining the read-only, record, and struct give you the fast, immutable, and the value-based identifier. Once we have defined the player ID as a strongly typed ID, we can change the type of player ID from the GUID to the player ID. This seems a very small change, but this small change gives us the compile time safety, clear intent, and better domain expressiveness. Now the compiler knows that this ID is not just a GUID, it's a player ID, and it is also not same as club ID. We also need to change the code where we have initialized this identifier before. Here, instead of saying GUID.new GUID ID, we will now initialize this ID as a player ID. Similarly, we can also change the type of this club ID property from a GUID to a strongly typed club ID. To achieve this, we need to create a club ID as a strongly typed ID inside this clubs feature folder. Let's add a new file club ID in the clubs feature folder. We need to mark it read-only, record, and struct. And here we can pass the value. Now we can change the type of club ID property from a GUID to a club ID. One more benefit of using the strongly typed IDs is that you can also use them in the method signatures. For example, if you check the constructor of this player entity, it is accepting club ID as a parameter, but this parameter is a GUID. Now we can change the type of this parameter from the GUID to the club ID. Similarly, inside this create method, we also have a parameter club ID, and we can change its type from the GUID to the club ID. One more place where the strongly typed IDs makes our intention very clear and saves us from many runtime error is when we pass them inside the repository. For example, if I open the iPlayer repository, you can see there is a method getById async, and this method accepts the player ID as a Guid type. But here, instead of using the Guid type, we can use the strongly typed player ID. This makes it very clear to the callers of this method that the parameter we need to pass should be a strongly typed player ID, not just a simple Guid. Let's go to the implementation of this repository, and here we also need to change this Guid to the player ID. Now this method will return the player entity matching with this player ID. Many people ask me the difference between the strongly typed IDs and the value objects. The strongly typed IDs are a special type of value objects. They are immutable, they represent a single concept, and they have equality by value. But their purpose is very focused, and that is to deal with identities. If you are using the entity framework, you need to make sure that the strongly typed IDs you have created in your application are compatible with the entity framework, which means the entity framework should be able to translate the strongly typed player ID to underlying Guid type which is available in the database. By default, when entity framework will generate the SQL queries, it will not be able to convert this player ID to underlying Guid. And to solve this problem, you need to tell entity framework how to translate the strongly typed ID to Guid. This configuration can be defined in the entity type configuration you create in your project. For example, for this player repository, I already have a player entity type configuration where I have told entity framework how to map this player entity to underlying players table. And this is where we already specified some configurations related to our player ID. To enable the conversion between the Guid and the strongly typed player ID, we need to use the method called hasConversion. This method will specify how the ID property will be converted from the strongly typed ID to the underlying database Guid. And here you can see I'm specifying that the value of this property will be created using a strongly typed player ID. And when entity framework needs the underlying ID, it will use the strongly typed player ID value property. This conversion will make sure that your strongly typed IDs are seamlessly working with the underlying database. Many developers ask me the question when we should use strongly typed IDs, and the answer is very simple. We should use the strongly typed IDs when we are using a domain-driven design, or when we are building a complex application where multiple entities interact with each other. If you are creating a small CRUD application, you may not need them. The good software design is always about the balance. Let's summarize what we have learned in this video. Primitive data types are not only dangerous, but they also hide the domain meaning. Strongly typed IDs improve the safety and the clarity of your code. They prevent bugs at the compile time, and they are perfectly aligned with the domain-driven design. If this video helped you understand the strongly typed IDs, please hit the like button. And don't forget to subscribe to my channel for more domain-driven design videos. Thanks for watching, and I will see you in my next video.